Okay. Hi, everyone. Hello. Am I audible right now?
You're audible. Your volume is a bit.
Voice is not
Now it's okay.
just fine, right? Okay. Okay. Just a minute. I think today's session is week 11, right? Week 11 solve with us. Not solve with us. Week 11 theory session, and most of this week 11 is actually is what like it's a recap of the previous session. Stats one and two, possibly I can say. Mostly it's stats two, and I think some more things have added into this. So what we can do is we can just see the previous things like in a little details, and then maybe if you have any doubts from the that from those concepts, right, you can ask me right now. We can go through those uh, concepts and then we move forward, because there is a very important concept we'll have to see today is transformed random variables or transformations of two random variables. Generally we know what is the transformation of one random variable, but we need to see that what is the transformation of two random variables, and that is I think a new concept to all of us, right? Fine. Uh, i and i'll be taking next two sessions also. So what we can do is week 11 12 we'll combine. First we'll complete the theory part of week 11 and 12, and later on we'll see the solve with the session from there. Fine, is that okay? Uh, right. So now I'm sharing a screen. I have created a small presentation. It's not like very, I don't know. It's not that great, I will say, but it is good to understand what exactly the concepts in stats are, right? So are you guys comfortable with all the concepts in statistics like PMF, PDF, and all?
Yes, sir.
All of you know? Shall I skip that? Yeah. No, no, not solve with us. Solve with us, we'll keep it later. Fine. So today we'll see week 11. In continuation to this, we'll do week 12 on Saturday, and after that, we'll one day we'll combinedly do solve with us for week 11 and 12. Because I don't think we'll have much time left ahead, right? So that in that way we'll do. What is the deadline, by the way, for week 11 and 12?
24.
Sir, 24th.
Sunday for both.
Yes, sir. For both.
Okay, okay. I don't know. Then we'll get time. Okay, we'll see. Okay, how can we do that? We'll see that. Let us at least try to understand the theory part of week 11 and 12, and then maybe, if time permits, right, we'll see these questions on solve with us also by Saturday itself. Okay. Okay. What are the concepts in week 11? Majorly this random variable, I think. And what is random variable? Can you just define the random variable for me?
So if there in a space, if something happens for that event, we assign it's a function basically, sir. So it takes an event and maps it to a real number R.
Okay, fine. And when we define random variable, we define the probabilities associated with it, right? So random variable can take, okay, it can take finite values or it can take infinite values.
So it can take infinite as well, I assume.
Right, as well as finite. So if it takes finite values, uh, we call, let's say if a random variable is x, right? Maybe, okay, this from another class. Okay, just give me a minute. I'll maybe open the notebook.
Yes, sir. Where can we get these notes?
Which notes?
Yeah.
The which the ones? This one which I'm showing you right now, or the ones I'm writing?
Both, sir.
I'm writing. I think I deleted those notes. I kept it. So
What about the slides, sir?
these slides I can provide you, but I don't know. These slides are very important. But if you want, I can share that with you. No issues with that. Fine.
Actually, we want exactly what is in the lectures. Like Sir explained
Okay.
properly
So
and
generally, these lectures,
explained.
right, it is related to how to find out the probabilities, how to find out, what is probability mass function and all. First of all, we'll try to understand that what is random variable, and okay, we will not go towards the how to find a probability. I think all of us know that what is probability, how we can find out the probability. We'll not go into that details, but we'll try to understand the probabilities in the context of random variable. So we'll see for first, like we'll see the probabilities associated with one random variable first, and then we'll slowly move towards the two random variables, and then we'll see what are the transformation and all. So before understanding that, okay, let's say if x is a random variable, right? It represents, let's say, number of tosses. Fine. It says the number of, or it represents the number of tosses uh, in which head appears. Or okay, let's say it says the number of heads in let's say 10 coin tosses. Fine. If this is my random variable, what do you think the range of x will be? The range means what values the x can take, what values the random variable x can take,
So 0 to 10.
0 to 10.
right? So because I have the finite number of trials, this is called as a trial, right? So in each trial, let's say, and when we say that 10 coins, right, or 10 coin tosses, that means I'm using one single coin for 10 times, and it is possible that I will not get any of the head, right? If I toss a coin for 10 times, and each of the time I will get tail. So if 8 coin tosses will get, or sorry, if all the tails will be get in 10 coin tosses, then I'll get, so x can take values, or x will be 0 when all the tails will appear in 10 tosses, right? It is possible that one head will occur and 9 tails will occur, right? Also it is possible that two heads will occur and 8 tails will occur, 3 heads possible, and like that, right? So you can have up to 10, right? Or all the 10 heads will get in 10 tosses. So if x represents the number of heads in 10 coin tosses, that means that this is the values x can take. Now, okay, I have defined a random variable, I defined the range. What now I need to define is what the probabilities associated with it. So what is the probability that x equal to 0? What does it mean? In 10 tosses, so if I say that these are the 10 tosses, right? These are the 10 positions: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So if I say x equal to 0, what does that mean? No
All are
head,
tails.
yeah, no
Only
head
tails.
in 10 tosses, and only tails. So that means at each of the position, I will get the tail, right? If this phenomena occurs, then I'll get x equal to 0. And suppose the probability of getting a head in one coin toss is, let's say, 0.5. So what we can say about probability that x equal to 0? If I use the similar coins, and again I'll say that whenever I toss a coin, right, the second toss is independent of the first toss. I hope you understand the concept of independence.
Sir,
Yeah.
I think there are 11 tails here.
1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, okay. I'll just add it on. Fine. Like 10, 10, right? Yeah. So all tails is this possible. So let's say, what is the probability here? It is 0.5 here, right? 0.5 here, or like the 0.5 is the probability of occurring tail, then 0.5 here, right? Each time I'll get 0.5, right? Here 0.5, 0.5, 0.5, 0.5, 0.5, and 0.5. So what is the entire probability? It will be 0.5 to the power
5 for 10.
10, right? So okay, what is the probability that x equal to 1? What do you mean by x equal to 1?
There is one head.
Then that means one head in 10 tosses. So but here it is a catch, right? So it will be not the it's not like the head can appear in any of the toss, right? So head can appear here, right? And remaining will be tails. Then head might appear here, and the remaining positions it will be tail. Then head will appear here, and the remaining positions will be tail, right? So that means head, I will get only one head. If I say if I get only one head, that means uh, 9 other tails will be there. But in what toss I'll get the head? Let's say if I get head in the first toss, or if I get the head in the second toss. So how to choose the position here? So how many ways the head can appear here in this fashion, right? So it will be 10c1, right? So one of the positions out of those 10 positions I will choose, and the probability of occurring head is 0.5, right? So it will be 0.5 to the power 1, and then the probability of occurring tails will be 9, right? 0.5 to the power 9. Okay, maybe I'll write down here. Probability that x equal to 1 is point 10 c1 0.5 into 0.5 to the power 9. 9 is 10 minus 1, right? So this is the probability of occurring head. This is the probability of occurring 9 tails, right? So that's the probability. Now can you understand? Now can you say that what kind of random variable is this? This is a special random
Binomial.
variable. It is a
Bernoulli.
binomial, right?
Randomly.
Binomial random variable. Binomial random variables. How will you get from IID Bernoulli, right?
Randy Bernoulli.
If I sum all the IID
Oh, sorry, you are not audible.
then it will be like n, right? N is number of trials.
Sir, your voice cut in between, sir.
Okay, now is it fine?
Yes, sir.
Yeah. So what is n here? Number of trials. In our previous example, how many number of trials were there? 10. These were the number of trials, right? In the fixed number of trials, we are seeing that what is the chance that this random variable will take the values, right? So suppose x will be the values taken by the random variable. So it is basically whatever we are doing here is this. It is the probability that x equal to x. Uh, so this random variable take the values x. X will these values can be what? Can be 0, it can be 1, it can be 2, up till 10, right? So it is ncx. P is the probability of success, and probability of success in this case it is head, the probability of head. So it is p to the power x, that many times head occurs, and 1 minus p is the probability of failure, which is, and here it is n minus x, right? Is that fine? So you can actually connect it here. N, how many n was there in this case? N equal to 10,
10.
x equal to 1, right?
1.
Is small x, and what is the probability of success? In this case, probability of head, which is p, is equal to 0.5, and probability of getting a tail, which is 1 minus p, which is 1 minus 0.5. Again, it was 0.5. So if you can compare these two, right? So here it was 1, and 9 means 9 I can write as 10 minus 1, which is n minus x. So this formula here I have written, it is a formula for probability. It is a formula for probability mass function, right? And in short form it is called as the PMF. So it is the probability mass function formula for which variable? So this is a special random variable. It is called as a binomial random variable. Okay. So initially I asked you that if any random variable, right, can it take the finite number of values or it can take infinite number of values. In this case, when I define a random variable as number of heads in 10 coin tosses, what you can say about the values taken by it? Are these values finite or infinite?
Finite, sir.
So these are the finite values. And when a random variable takes finite values, then that random variable is called as a discrete random variable. Is that fine? So if the values taken by a random variable, they are countable, right? In that case, so let's say if let's say hypothetically, let's say if any random variable x is there, and if it takes 200 values, 200 values it can take, then or in other words, I can say the range of that. So it is also called as the range of x, right? Range of x. But suppose if it can take 200 values, uh, then in that case it will be a discrete random variable or continuous random variable.
Discrete.
Discrete.
Discrete, right? Even the values are larger, right, by random variable, still we can't call it as a discrete random variable because these values, right, even though they are larger, they are finite. Fine. So that's why it is called as a discrete random variable. Now you can see that a PMF, right, which assigns probabilities to each possible value of a discrete random variable x. And okay, one more question here is: can the random variable or can a discrete random variable take negative values?
Yes, sir.
Yeah, it can take negative
Yes.
values, right? Yeah. But can it take the or whatever the random variables it is, the values taken by random variable, if they are negative also, can they have the probabilities negative?
No, sir.
No.
No, right? So uh, remember that if a random variable x, right, if it is a discrete random variable, let's say we are anyway talking about the discrete case, we will have the probability mass function. And okay, in this case I have written the probability mass function as like this. So okay, I'll just summarize it again for a binomial random variable. So x is a, let's say it's a binomial, or generally it is written as like this. So I'll also write according to the convention. So it is x is binomial with n p. What is n and p here? N denotes
Number of successes.
number of trials,
Number of trials. Number of
right?
trials.
P is,
P is probability.
Probability of success.
Probability.
yeah,
Probability of
probability
success.
of success, but of each trial, right?
Yes. Yes. Each trial.
Yes.
That is also important, right? It's not like entire probability of success. It's the only probability of success each time, because binomial is, I told you, right, it is a sum of IID Bernoullis. So binomial is basically the sum of IID Bernoullis, right? And what is the range of x? X can take values between, let's say,
0 and n.
0 and n or 0 to n.
0 to n.
Yeah, so it will take 0, 1 to 2 n, right? uh, in this case, can it take the values which are, you know uh, like decimal values, binomial random variable?
No, sir, it cannot.
All right,
No.
because
Not this.
it will be like always 0 1, either 0 success, either 1 success, either 2 successes or 3 successes, and maximum successes we can get in any trial is, or any binomial trial is, n, right? Fine. Okay. And now if I define, let's say if I create a table like this, I can actually define the probability mass function in two ways. uh, this is called as the probability of x equal to x, what will be the probability for each year? This will be nc0 p to the power 0 and or like 1 minus p to the power n, right? Here it is ncn p to the power n, and like that in between. So I can write this table as like this, or and this is also called as a PMF, right? Probability mass function table or probability mass function, or I can write the probability mass function as like this. Probability that x equal to x is n c x p to the power x and 1 minus p to the power n minus x, where x can take values, or I can say that where x can take values in 0 to, is that right? This is also called as a PMF, probability mass function. This is also probability mass function. So x here, which is a binomial random variable, is a discrete random variable, and the the probability mass function formula for this is ncx p to the power x 1 minus p to the power n minus x, and where x can take values between 0 and n. Is that all right? So okay, so now we can see the properties. These are the properties of PMF. What is it? The probability of x equal to x, right, is always positive or 0. It can be greater than or equal to 0. The probability taken by a random variable, right, or the values taken by a random variable, they cannot be negative. That is point number one. So I have seen the students writing probability values as -5, -2000, -300, something like that. Is it possible? No, right? So whenever you write into the exam, right, even though if you're not confident about your answer, but you should have the range of probability. So what is generally what for any value, right, what is the probability value it can take for any
0 to 1, sir.
0 to 1.
so the probability value should
Zero
be
to one.
between 0 to 1. So it cannot be less than 0. That means it cannot be a negative value, or it cannot be a positive number, right? More than 1. Correct? So whenever you are writing, right, and if you are confused with the answer, if you are not able to write the answer properly, or you are not getting the answer and you are just guessing the answer, right? Whenever you are guessing the answer for probabilities, it shouldn't be negative, or it cannot be a very big number, right? Like maybe not big also, like 2, it cannot be 2, it cannot be 1.5, it cannot be 3, it cannot be 3000. So when we see the whenever we see the quiz, after the quiz, right, when we see the numericals, we can found out that there are students, multiple students, right, they write the probability values as negative values or some values greater than 1, but that shouldn't be the case, correct? So
But you're also trying to trick us.
sorry.
But I think you are also trying to trick us. No? Maybe
That is okay. So tricking
this
is
time
fine.
I found.
Yeah, but is it possible to get?
Yeah,
See,
yeah, sir.
let
In the last quiz, no, most of the options are also similar.
okay. Okay, that is fine.
Now
That is
you are trying to trick us.
okay. That is fine. But even though the if let's say if I'm sitting for the exam, right, should I write the negative value for probability? It's not possible, right? Even if it is there. At least see, if I don't know the answer, what should I write? I can write 0.25, I can write 0.5, I can write 1, I can write in any value between 0 and 1, but it shouldn't be, or I can write 0 even, right, if I don't know the answer.
Yes, sir.
But it shouldn't be -5, right? So that means there is like almost 0% chance that your guess will be correct. If you are guessing the answer, right, at least guess it so such that there will be some probability associated with, positive probability associated with that, you can get the correct answer, right? Right. So okay, what did he saying again? What is the second statement saying? The sum of the probabilities, right, across the over the range of the values taken by the random variable, they should be equal to 1, correct? So in this case, uh, what it should be, how should I write it down here for binomial random variable? So summation over x ncx p to the power x and 1 minus p to the power n minus x should be equal to 1, right? So let's say I should, if I add this probability plus this probability plus this probability and all, it should be equal to 1, right? So x, let's say here it's nc0 p to the power x, p to the power 0, 1 minus p to the power n plus nc1 p into 1 minus p to the power n minus 1 plus nc2 p to the power 2 into 1 minus p to the power n minus 2, like that till ncn p to the power n and 1 minus p to the power 0, right? It should be equal to 1. So what are the properties of PMF? Probability mass function is that the probability, each of this probability, right, the value taken by random variable should be greater than or equal to 0. That is first. Second is the sum or the range of the values taken by a random variable, probability that x equal to x should be equal to 1. Is that fine? Is that all right? Any doubts so far? No, right? Okay. Uh, okay, this is the case. This is a simpler random variable. What is this random variable here?
Bernoulli.
Bernoulli random variable, right? So Bernoulli is a very important random variable. I think we all should know. So
Very basic.
yeah, and uh, it is associated with this one, right? Like whether if I toss a coin, right? If I toss a coin, what should I get? What are the outcomes of that tossing a coin? How many outcomes are there? First of all?
Two
Two.
outcomes.
Yeah, two outcomes are there. So if I toss a coin, I'll get. I will have two outcomes. Let's see. So if I toss a coin, right, I will x will be what? Either head or tail, right? It will take only two values, uh, and if the probability associated with it, right? So probability that x equal to x, if I get head, the probability is 0.5, and if I get tail, the probability is 0.5. In that case, what uh, what what is this? There is special name to this, and what is that special name?
For what?
Having the two probabilities similar, or
Uniform
uh,
distribution.
yeah, so okay, there is an uniform distribution, that is fine. What else?
Identically distributed.
IID, sir. If they're
IID.
identically,
IID is not this. No, IID is like if I toss a coin multiple times,
That
oh,
is
yes,
IID.
yes, yes.
right? If only I toss one coin, and if I get this, okay, maybe
Fair.
yeah, fair coin. Yes, right. Fair or unbiased, right? Let's say if this is
Yes.
body, right? Uh, so this is called as a fair coin, right? When I say the fair coin, what does that mean? The probability of getting a head and probability of getting a tail is same, right? Which is zero point 0.5 and zero point 0.5, correct? And this is
Success
called
and failure is same.
correct, and this is called as the unbiased coin as well, right? Unbiased coin. Is that fine? And this is called as a biased coin. So if if I toss a coin, and if I say that if I toss a fair coin, what does that means? The probability of getting a head and probability of getting a tail is equal, right? That is equal to zero point 0.5. So okay, so in this case, what is the verification we are doing here? The probability of x equal to 0 is zero point 0.5, which is greater than or equal to 0. Probability of x equal to 1. Okay, you can choose 0 as, since it is a number of heads, right? So probability of x equal to 1 means what? Probability of head, correct? And probability of x equal to 0 means probability of tail, fine? And this is actually 1 minus p, and this is p. So you can see that these two probabilities are greater than or equal to 0, and if I sum up the two probabilities, I'll get 1. So that means uh, this is a valid PMF, right? So what is the probability mass function here? If I toss a coin once, it is x will take two values 0 and 1, and probability that x equal to x is zero point 0.5 and zero point 0.5. So if this happens, then it is called as a, this is the probability mass function, right? This is the probability mass function, and if it satisfies both the properties, then it is called as a valid PMF. Correct? I hope it is fine till now. All this bias, what is biased, what is fair, what is unbiased point, and all. Actually, bias and unbiased will have different meanings to it, but we'll see that later. But right now, do you understand this part?
Yes, sir.
Okay, fine. Okay, so if I dice a roll, right? So if I dice a fair die, what does that mean there? Now, when I say fair die, that means, okay, what are the outcomes of rolling a fair die?
1 to 6.
Right. If it is a six-faced die, then it is having one, two, three, four, five, six. These are the outcomes of a rolling of a die. If I say if it is a fair die, what does that mean?
Probability of all outcomes is same.
Same, right? And that has to be equal to one by number of outcomes, right? Number of outcomes, correct? And how many outcomes are there? In
6.
six. So each of this number will have the same probability, which is one by six. And what do you think about that? Is it greater than or equal to zero? Yes, right. And if I sum over all these probability values, then I'll get it as equal to 1. All right, the sum is getting equal to 1. I hope no issues are there till now. Okay. So if you find any difficulties, right, you just let me know at any point, and then I can uh, revise it again.
Sir, in this dice case, the probability mass function is just 1 by 6. If they
No,
ask us what is the probability mass function,
no. Probability mass function will be this. No, x will take values one, two, three, or you can say this is a probability mass function, or you can write it as like this in tabular format as 1 2 3 4 5 6. That x equal to x is 1 by 6, 1 by 6, by 6, 1 by 6, 1 by 6, and 1 by 6.
got it, sir.
This is your probability mass function, or you can write in this way also. This is also probability mass function. Fine. Okay. Tossing two coins, then okay, if I toss two coins, and if this is my random variable, that is number of heads when tossing two coins, uh, what do you think, how many outcomes are there, or it will take what values here? Number of heads when tossing two coins.
4.
4.
What are those outcomes?
Head, 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 tail, tail, head.
Tail head. Tail tail.
Yeah, so if I write down all the outcomes will be like this. Say, okay, I should write a set, right? So it can have this equal to maybe one event will be head tail, other event will be head head, let's say. Then one more will be tail head, and another will be tail tail. Correct. These are the outcomes. These are individual thing is a event, right? I hope all of you understand that part. What do you mean by event? This is an event, right? Okay. And when I say x equal to number of heads, so what is the range of x here?
0 and 2.
Right. So I can get zero heads. What is that outcome? Which one is this?
TT.
This one. If I get one head, which are those two outcomes?
HTTH.
Head T and or THT or TH, right? That is one. And if I get two heads, right? Apart from that, x will not take any values. Then if I wanted to find out what are the probabilities associated with it, so if I say x equal to 0 means which event?
1 by 4 tt.
This event, right? And what is the probability of this? So out
1
of
by
0,
4.
it is coming as 1. So the probability of x equal to 0 is 1 by 4. What about 1?
2 by 4.
1 heads occurs 2 times, so it is
1 by 2.
2 by 4, which is equal to 1 by 2. And x equal to 2 is this one,
1 by 4.
1 by 4.
4. So my probability mass function here will look like this. So I can write it as like x equal to 0, 1, and 2. Probability that x equal to x will be equal to 0.25, 0.5, and 0.25. Is that fine?
Sir, 1 0 1 2, how it came, sir?
So okay, how many heads?
X belongs to
If I wanted to find out number of heads when tossing the 2 coins, so when I toss 2 coins, what are the outcomes? HT,
head,
TH,
hmm,
HH,
head,
and
tail.
TT, right? If I say number of heads, number of heads equal x equal to 0 means
No head, sir.
no heads, which is there. Okay, how many of these outcomes will have no heads?
Mm,
One outcome,
1.
right? So when I say x equal to 0 means which outcome? Only, sorry, x equal to 0 is this outcome,
1
right?
by 4.
TT, right, is the outcome, and the probability of x equal to 0 is 1 by 4,
1
because
by
out of this 4 it is
4.
happening one time. When I say x equal to 0, x equal to 0, sorry, x equal to 1, what is it? Which two out, or how many outcomes it will have?
3.
X equal to 1 means
Oh, sorry, 2.
one head, right? So one head occurs here and here. So two outcomes, and the probability of that will be, the probability is 1 by 4 here, 1 by 4 here, right? Because the probability of occurring all of them is same, 1 by 4, 1 by 4, correct?
Okay.
And if x equal to 1, that means I'll have to add these two probabilities. So it will be 1 by 4 plus 1 by 4, which is equal to 1 by
2 by 4.
2. 1 by 2, yeah, 2 by 4, which is 1 by 2, which is equal to 0.5 again. So that's why I written here 0.5. What is x equal to 2?
1.
Number of heads equal to 2. Yes. Oh, sorry. I think I done it wrong there, right? Previously. These two events. And now only head is this event. Correct? So what is the probability of getting this event? 1 by
1 by
4.
4.
Right. And how this 1 by 4 comes, that also you know? If
Yes, sir.
if the fair coins are there, then I should, what is the probability of getting head on one coin?
1 by 2.
2. And what is
1 by 2. By adding together, 1
multiplying?
by 2.
Not adding, multiplying, right? So it is like two tosses, right? And independent tosses, and then it will be like in the probability of multiplication. So it will be we are multiplying the probabilities here. Okay. Okay. So similarly, if the range of x, right, or the values taken by a random variable, they are infinite, then we call that random variable as what? A continuous random variable. Fine.
So,
Yes.
sir, uh, range is called a support, no, in continuous space.
Yes, support, but support when we say it's like when we consider the joint density, when we consider
Joint
the two
density.
random variables, yes. Otherwise, we call it as range only if it is of one random variable, or you can call it as support also. It's not a problem that way. But see, generally, it's like mathematically or statistically, if you think about it, right? Most of the books use support when we are calculating the probabilities for multiple random variables. That is more than one random variable. Okay. Fine. So, okay, the same formulas or same properties are applicable to probability density function also, right? Or we can short form for this PDF is probability density function. It is probability density function. And the previously we have seen is that probability mass function, which is PMF, right? So for any discrete random variable, we call it as PMF. If the random variable is continuous, then we call it as PDF or probability density function. What are the properties we have seen for PMF? That one is what?
Sum of the probabilities is 1.
Okay, sum of the probability is equal to 1, and
Probability
Each
is greater than or equal to
Probability is
0.
greater than 0.
for each of the value taken by a random variable, the probability is equal to or is greater than or equal to 0. The same thing is applicable here. The only thing is that there we are doing the summation, we do here integration, right? And we are actually not finding out the probabilities at single value. Rather, we uh, integrate over the uh, a shorter interval, right, which is dx. So I hope you understand that part. And okay, I'll not go into detail because we don't have much time to understand that. But you just think about it as like the probability at one point, right, in the continuous random variable is equal to 0, right? But if we think about it over the range of over the range or a shorter interval, it will have it should be greater than or equal to 0. But that is fine, that is okay. Right now, if you think about it, what is this? You're finding out the probability over a range, right, which is or over some interval, not range, over some interval. This will be a to b, and here it is minus infinity to minus infinity to plus infinity f of x dx, and the integration should be equal to 1 here. Similarly, I can find out the probabilities over an interval. Let's say if I take a shorter interval. So for example, I'll take an example of a normal distribution, right? I hope all of you are uh, familiar with this bell-shaped curve, which is a normal distribution curve. Sometimes it is called as a Gaussian distribution curve as well. So let's say this is your normal distribution curve, and let's say it has this mu which is mean, and it is called as sigma. So these are the parameters, right? These are called as the parameters. In binomial case, what were the parameters? Case we have seen.
N and T.
Yeah, these two were the parameters, right? In binomial case, these were the parameters. In normal distribution curve or normal distribution, mu and sigma are the
Mu
parameters.
and sigma.
Yes. So mu is what? The mean, and sigma is
Mean.
what? Standard
Standard
deviation.
deviation.
Variance.
That's mu square
Variance
and
will be
sigma
sigma
square.
square, and sigma is your standard deviation. All right. Okay, so if I wanted to find the probability between, let's say, these 2 points, let's say A and B, it will be a integration from A to B f of x dx. If I wanted to find, or what is the probability under this curve, under this normal distribution curve, from, let's say, it is from minus infinity to plus infinity,
1.
value should be equal to 1.
1.
Okay, I hope till now this is clear. Okay, this is one of the simplest example of probability density function, which is uniform distribution, right? So there are two uniform distributions. One is discrete uniform, another is continuous uniform. In the continuous uniform case, what is the probability? Uh, what is the probability of, let's say, if a random variable x is uniform over this A and B, then the probability density function for this will be, and generally it is denoted by f of x, right? Probability density function, or yeah, probability density here. And what is the probability density function here?
1 by
1
b
by b
minus.
minus
B minus A. And if it is discrete uniform, then in that case, so discrete uniform case will be like this, right? So x is uniform over the set of numbers, let's say 0, 1, 2, and 3 in this case. What is the probability? Uh,
a.
the
1 by 4.
probability mass function in this case,
Every value will take 1 by 4.
it is 1 upon 4, right? Which is total number of values in the set, fine, or the number of values the random variable takes. So that is the difference between your uniform distribution and the or discrete uniform and the continuous uniform distribution. All right. Okay. So next is your. I think this is also a famous distribution. The exponential distribution. Generally, it is written as like this: x is exponentially distributed with the parameter
Lambda
lambda, and this is what? This is your PDF, which is probability density function, which is lambda e to the power minus lambda.
minus lambda.
And what is the range, or what values it can take?
Non-negative.
So it will take from uh, all values greater than or equal to 0. So 0 to infinity it
0 to infinity.
can take, right? Okay, and you can check that whether the probabilities are equal to 1 or not. How do you check it? So basically you just integrate from 0 to infinity, right? Lambda e to the power
Lambda e to the power minus lambda x dx equal
dx,
to 1.
and suppose your lambda is equal to 1, then in that case it will be 0 to infinity e to the power minus x, right? Not lambda x now, because lambda equal to 1 will be minus x dx. Okay, fine. All right. So
Sir, in exponential, the value of the random variable cannot be negative.
no, in exponential distribution, right, it should be always greater than or equal to 0.
Sir, one more question. Lambda, I remember in studying statistics 1 or 2, lambda is it the mean or the standard deviation or the
Rate parameter. Lambda is
No,
rate parameter. Rate parameter.
it is neither mean or it is neither standard deviation, right? The mean for this distribution is what? 1 upon
1
lambda,
by 1 by lambda.
and the standard deviation is, or the variance is rather, right?
1 by lambda square.
Case
Is 1 by lambda
this
square.
case is 1 by lambda. So generally it is written like this, right? Expected value of
E of x equal to 1 by lambda.
lambda, and variance of x is
1 by lambda square.
lambda square.
got it, sir? Remember now, sir. Yes.
And it is lambda in which case? In a discrete case, there is discrete
Uh,
variable called,
Poison.
yeah.
Poisson distribution.
If it is a
Yes, sir.
Poisson random variable, in that case, expected value of x is equal to lambda, and the variance of x is also equal to
Lambda.
lambda. Okay.
Did we
So
get this formula?
I think we don't explicitly give those formulas, but you can see it, like I think for stats it is given, right? And I think
Yes,
it is a
yes.
common information, so you can actually go there and you can find it out from there. Okay. Okay. This is a PDF for normal distribution, which is generally okay. I think it is written as like this, but how generally it is written as PDF for normal distribution. Okay, I'll summarize the distributions here. The, the discrete distributions, and let's say the continuous distributions. Sorry, continuous distributions. Uh, the most common distributions we are talking about. One is Bernoulli, right? What is the PA, sorry, PMF for this Bernoulli distribution? P and 1 minus P. At the same time, I'm just writing down the expected value also here. What is the expected value of x here? Basically, in discrete case, right, the expected value of x will be what? It is equal to
P.
summation of x into x into what is that, x equal to x, right? So x is the value taken by the random variable. So in this case, it will be okay. I think I have written it wrongly. It should be like this, right? Product of success here and 1 minus p here. So it will be
P.
0 into 1 minus p plus p into 1. So that will be equal to p. And the variance of x will be p into 1.
Variance is P into 1 minus P.
Right. So there is another very famous distribution, which is sum of IID Bernoulli's. It is called as the binomial distribution. Uh, and, and it will have two parameters, n and p. write down like this. Maybe the correct notations will be like this. X is Bernoulli with
T.
parameter T. Right. In this case, what is the PMF for binomial distribution? It is
NCK
NCK
no. But
minus
if I take X here, then it should be X, right? So NC small x, or if you want to take K, then that also is fine. So I can just say that K, which is then NC NCK
into P to the power X, P to the power K into 1 minus P to the power N minus K.
right? And what is K? K will go from 0 to,
0 to N.
N.
and what is the expected value of this binomial random variable?
NP.
N into P.
NP.
And the variance of this binomial random variable will be
NP into 1 minus P.
into 1 minus P, right? Okay, I think I'll write down one more. One more, I think, very important random variable is there, which is called as a geometric random variable, right? And what are the parameters of geometric random variable?
P.
P only, right? One parameter. In this case, what is the probability mass function for this random variable?
1 minus P to the power K minus 1.
So it
P
is like
into 1 minus P.
we are.
1 minus P to the power N minus K into
It is generally
P
okay.
into 1 minus.
It has to define it properly. But let's say if it is defined like this, let's say, uh, what is the probability of getting a success in the kth trial? Right?
First success.
So getting a first success
P.
into the kth trial. So it will be
P.
like that means
P.
until k minus one trials, you don't get any success.
1 minus
So
P.
it will be 1 minus p to the power k
K
minus
minus
1
1 into P.
into p. So
Into
that is
P.
my probability mass function of uh,
Geometric distribution.
automatic distribution, right? Just a minute, I'll just plug in the charger. Okay, fine. So then what we need is we need what is the expected value of this random variable, geometric random variable, and that is, I think it is equal to 1 by
1
p,
by P. 1 by P.
right? And variance, I think it is complicated function or something like that. I don't know, but it's fine. I don't remember the formula for that, but I think it is this. This is fine. Then one more very common,
Variance. Variance is 1 minus P by P square in this case.
yeah, variance. Okay,
Hmm.
thank you.
Yeah.
I think it is 1 minus p by p square. Yes. Yeah, you can cross check it, maybe, but I don't remember right now. Fine. So the fourth very important, I think, generally occurring random variable, discrete random variable, is Poisson random variable. And how many parameters it will? There is one more, hypergeometric. We don't generally use it in our syllabus, but it is there. I think it is a part of stat syllabus, right?
yes.
Yeah. What is the parameter here? Poisson random variable. It's a lambda, right? It's a average rate at which the values are being taken, right? Or like that.
Number of events.
Yeah. So what is the probability mass function in this case?
E to the power minus lambda into lambda to the power x by x factorial.
X factor, right? If I take x, or if I wanted to say k, then it will be
K or any variable.
yeah, correct. So and what is the expected value of x here?
Lambda.
Lambda, and in this
And
case, the
variance
variance
is
of
also
x is
lambda.
also lambda. So these are the most commonly occurring random variables, discrete random variables, I'll say. Okay, and okay, I think didn't write explicitly the variance formula here, but what is the variance formula in the discrete case? Will be not I equal to, it is like over the range of x, right? So I'll say that x, it is x square into, is that correct? And what about the continuous case? What is the expected formula for expectation formula here? It will be integration
X into fx.
Range of it.
over the range of x, right? Let's say, and
X.
it is equal
X
to
into fx.
x into f of
fx.
x dx,
Yes.
right? That you will have to integrate over there, and you will get. And similarly, what is the variance formula in this case? The variance of x,
X square
it will
f
be
of x dx.
integration over the range, right? With x square, or you can find it out like x square dx, f of x dx. Fine.
What was the formula you wrote
This
down?
is expectation of x square, right, sir?
Sorry.
Not variance of x. What is variance of x? This
Oh,
is
sorry.
expectation
Oh,
of x square, right?
yeah, sorry. Yeah. I think I have done the same mistake that side also. Discrete also. Basically, variance of x is it is
Expectation
expectation of x square
x minus
minus
expectation of
Minus
x.
expectation of x
to
whole
the
square.
whole square. Right.
Yeah.
And I think that also is for independent case, not like if they are decorrelated, right? I think then only we can use this formula. Otherwise, it's like another expression, right? I think that expression here is it is sometimes it is written as like the expectation of x minus
X minus e of x whole square.
whole square, right? It's like whole square, correct? Okay, okay. The formula previously I have written, it was of, I think here also that same mistake is there. Can just fine. So for this continuous case, I was writing continuous case. What is expected value of x square? It is just over that range, right? Let's say 0 to x, or any minus infinity to x square, x dx, right? That will be your expectation of x square. Okay. I'll write down the common distributions. Okay, one more thing. I haven't written those common distribution, like both uniform distributions. These are also very important distributions anyway. But assuming that we have already seen that earlier, I've I didn't write it here. Uh, the important two important distributions we look in exponential. Sorry, in the continuous case. One is exponential distribution. So x is distributed exponentially, right? So x is okay. What is the parameter in this case? Only one parameter, is lambda here. What is the probability density function, right? So it is now, since it is a continuous case, we don't say probability mass function, we say probability density function, that is pdf. So pdf in this case will be lambda e to the power minus lambda x. Fine. And what is the expectation of x is 1 by lambda. You can integrate this pdf between 0 to x, you will get that 1 by lambda, and then you will variance of x in this case will be 1 upon lambda square. Then another very important distribution is I think that is what we are going to learn over week 11 and 12 is this one, which is normal distribution or Gaussian distribution, right? Or Gaussian random variable. So if x is normally distributed with some mu and variance sigma square, in that case, what will be the PDF of x? It is 1 upon root 2 pi sigma e to the power minus x minus mu to the whole square by sigma square. Fine. And what is the range of this distribution, normal distribution? It is minus infinity to plus infinity, right? So x can take any value from minus infinity to plus infinity. Fine. Okay. And this is not, there is no closed form solution to this. That means we cannot find the probabilities exactly. So we use what? The tables, right? And there is special case to this normal distribution, which is mean is 0 and
Variance is 1.
variance is equal to 1, right? And
Standard
then
normal.
this is called as a standard normal. Standard normal, and generally it is denoted by Z, right?
Z.
Z, standard normal, right? And if you are given any particular random variable x with mu and sigma, do you know how to convert it into the standard normal? So Z can be written, right, in a standard normal fashion, or for any random variable, right? Rather, it's not like only related to the normal. Any random variable can be written into the standard normal by by this formula x minus
U by sigma.
by sigma. This is called as this Z is called as standard normal variate, right? And when you find out this probability, how to find out this probabilities? Actually, we can find it using the CDF, right? That is cumulative density function. Okay, that
Yes.
okay. So till now we have seen, okay, these are the important distributions here. We have seen some expectations. We have seen some. Okay, I'm not going into very much details, right? Because we do not have much time to cover all of these topics. But assuming that all of you know at least this basics, do you know about the joint densities? Joint density, conditional density, marginal density.
Yes, sir, but
Okay,
we need to refresh based on the questions we may get.
okay. So I'll just write down a certain table. Like we'll see it for only, let's say, for a discrete case. I will leave it for you to see from the continuous case, because I need to jump into this transform.
Could you tell continuous case instead of discrete? Because in week 11 lectures they mentioned continuous explicitly.
That is fine, but if you don't understand the discrete, will you be able to understand the continuous case? What is the marginal density and what is the conditional density? I know. Okay, maybe we'll see. Like, okay, let's see both the cases. Okay, we'll try to see that. No issues.
No, it's all in stats too. Stats too. Already we have studied all this.
Yeah, that's what I'm saying.
Yeah,
We all
that's what. So you can go ahead.
uh, okay. Whenever is required, then we can see it possibly, right? Those who have any doubts, right? Maybe I can take it later to have. And so maybe I'll cover the important topic here from week 11, and I think, and which is the new one possibly for all of you. Uh, but before going there, I will. Uh, okay, I'll say one thing. Let's say I will show you one case. Let's say if x is what uh, x is okay. Take simple example here, which is uniform, or let's say Bernoulli. Uniform. I'll take uniform, right? So uniform. It is a discrete case with it will take values 1, 2, and 3. Is that fine? X is a random variable with uniform 1, 2, 3, and suppose f of x is equal to x square, right? I'll write this f of x as y. Is that fine? So I define a new random variable y, which is a function of the random variable x. Okay, and what is that function? That function is x square, correct? Okay, so and if I ask you what is the distribution of y, can you tell me what is the distribution of y?
Sir,
How to find?
149, uniform 149.
So what do you do in this case? If you try to find out its range, right? What is the range of y? Correct. So, or what are the values taken by y? X takes values 1, 2, and 3. So x will, if x equal to 1, what is the value of y? it is 1 square, that is equal to 1. If x equal to 2, y equal to 2 square, which is 4. And if x equal to 3, y is equal to 3 square, which is 9. So x takes values 1, 4 and 9. What about its probabilities, right? So probability of y equal to 1, that is equal to what? Probability that, okay, what is y? X square, right? So x square equal to 1. So if I do it, then x will take values what? X will take either plus
Plus 1 minus
or minus 1. So I can write either and or in probability scenario. It is probability that x equal to 1 or probability that x equal to minus 1. So in this case, what is the probability of x equal to 1? Is 1 by 3.
1.
Probability of x equal to 2 is 1 by 3 and probability of x equal to 3 is 1 by 3. So what is probability of x equal to 1? 1
1
by
by 3.
3. Or means it's a logical.
Plus
So it is plus. What is probability that x equal to minus 1?
0.
0, right? So only for the values 1, 2 and 3, x will have discrete, x will have the probability greater than or equal to 0. For other values, it is equal to 0. So it is equal to 1 by 3. So the probability that y equal to 1 is 1 by 3. Similarly, you can show that the probability of y equal to 4, it will be, because then it will, if I do 4 here, it will be plus or minus 2, the probability that x equal to 2 and probability of x equal to minus 2. Then again it will, you will get the similar distribution. So this is what we have done. This is a function of a random variable, right? So suppose if I say y is a function of random variable, sorry, y is a random variable with this distribution 1, 4 and 9, uniform discrete random variable with this 1, 4 and 9, and suppose y is a function of x, which is equal to x square. Now if I say that, what is the distribution of x? How do you find it out now? Previously we were able to do it. Now how do you find it out? So I
Root
can
y.
write x as what?
Root y.
Root y.
Okay, and what do you do then? So you are writing x is in terms of f of y, right?
F of y. Yes.
Or
Yes, sir.
or can I say that it's kind of f inverse of y, right? Or sorry, f inverse of x. So I can write f of x as x square, which I can. So if I wanted to write what is x, then it is basically
F inverse of y.
y, right? Sorry, f inverse of y, right? F inverse of
Yes.
y or f inverse of x.
No, here it is y equal to x square,
Yeah,
right?
sorry,
That's why
f
it's
inverse of
coming
y.
in
Yeah,
here.
correct. So okay, that's fine. So now I can write x as a function of y, right?
Y.
And
Yes.
now I can find it out like again. So if it is root y, then I'll find out what is the range of x. So when y equal to 1, what is x equal to? It is root
Plus
of
minus.
1. It is no, root of 1 is
Sorry,
1.
sorry, sorry. 1, 1. Correct.
When it is y equal to 4, then x equal to
2.
4, which is 2. And
2.
when y equal to 9, then x equal to
3.
root of 9
3.
to 3. And similarly, I can find out what are the probabilities, right? So if now I found out this is what the range, right? What is the probability that x equal to 1? I can find it out that what is x? It is root of y equal to 1, right? Right.
1 by 3.
Or I can say that y equal to 1 square, which is 1, and that is equal to 1 by 3. So similar thing we can actually find it out. This is what we have seen, right? It is a transformation of a random variable, but it is a transformation of a single random variable. So that means if I know the distribution of one random variable, and if that random variable is associated with another random variable, right, I can find it out the distribution. Let's say in this case, if I know the distribution of x, can I find it out the distribution of y? Yes, right? And if I know the distribution of y, can I find out the distribution of x? That also is possible, right? So this is called as a transformation of a single random variable. Generally we call it as a function of a random variable, but this is what it's a transformation of single random variable. Now I need to.
Sir,
Yeah. Yes. Yes.
in that case which you just showed,
Yeah.
don't we have to take into account minus as well?
Where?
I mean, x equal to root 1.
Huh?
So x can be plus and minus 1,
No.
right?
No. 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 Root of one is not plus or minus one, right? Is it possible? No, I guess not. Root of any number is only single number, right? It's not like plus or minus. Is it? Root of 4 is plus minus 2, huh?
Modulus means a plus or minus.
Yeah, okay, okay. Root of, that's true. Okay, fine. I don't think we'll have. What is what are you saying? Modulus?
Modulus will be plus or minus. Now for root it won't be.
But here we have written it, right? Previous case, when x square equal to 4, we have said x is equals to plus or minus 2, right?
But in order to be a valid function, it
Yeah.
has to return a single value, right?
No, here it has to be single value because
Single value.
Single value.
even if it is two values, no, no, I think no, 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 no. Here shouldn't take plus or minus 1. It has to be positive, right? In this case. Yeah. Okay. So okay. So the motive for showing this thing is that, like, this is called as a transformation of single random variable. Similarly, I can have transformation of two random variables, right? But then how to go back and forth over this transformations of single random variable, we'll try to see it now. Now, uh, and okay, the way to find it out is by using the joint PDF of two random variables. So suppose, so I'll just write down some things. Okay, transformations. So two random variables. Okay. Now let us say there are two random variables, x and y. Okay. Uh, X and y are the two random variables for which I know the joint density of them. And generally, the joint density of two random variables is written as f of xy, which is f fxy x comma y. Fine. So when you have this two random variables x and y, I know their joint density. There are two more random variables. They are defined as like this: x is a function of let's say w and z. Fine. So there are two more random variables which are w and z, and I'm saying that it is a function of, this is r means is kind of some function of w and z, and y is a function of some other function of w and z. This setup is clear. I know this is known to me. The joint density of x and y is known to me, but this x, right, x is a function of two other random variables w and z. Similarly, y is a function of two other random variables uh, w and z, right? But they are two different functions of w and z. So now the question is, I wanted to find out the joint density of, I wanted to find out uh, the joint density of w and z. So how to find it out? The formula for this is what is known to me: joint density of x and y, right? So I'll say that, uh, so I'll just put it down here, f of, instead of x I'll write r of wz, and instead of y I'll write s of w comma z, and into the Jacobian. Fine. I'll tell you what is that Jacobian is. I think you'll understand it through the numerical which we are going to solve. But right now, you just understand that I know the joint density of x and y. I know that x is a function of w and z, and I know that y is a function of w and z. W and z are two different random variables. Now, question is, I need to find out what is the joint density of W and Z. Okay, and this is the joint density is given by this formula, which is this. It looks very difficult right now, but when in application side, it is actually a very easier formula. So this notation here, it is called as a determinant. It's not the absolute value. Maybe I'll write it down here. It's basically, it is a determinant of absolute value of J. Fine.
It's always positive, right?
Yeah, so actually we are taking the absolute value for that.
It's the modulus of the
Modulus
determinant.
of determinant, yes. So what is determinant of J? It is del R by del W, then del R by del Z, and then del
S by del W.
S by del W, and del S by del Z. Okay,
Del Z.
fine. So I'll show you an example. Maybe then you can able to understand it better. So the one example I'll tell you is that, let us say x and y are the two random variables with joint PDF as this 1 by 6. Fine, and x is in between 0 to 2, and y is in between 0 to 3. Fine, and there are two random variables w, which are what, uh, they are like this, x plus 2y, and there is another random variable z, which is a function of x and y, is, let's say, 2x plus y. Is 2x plus y. Okay, now I need to find out what is the joint density of, what is the joint density of w and z. This is my question. So by looking at it, what should I need to do first? I need to find out the determinant of Jacobian first, and then I will just plug in the values of r these functions into this. So what do you think here? I know x. I know this w. I know, sorry. I know the x and joint density of x and y, but I don't know the joint density of w and z. So first thing I need to do is what? Whatever I know, right? This x and y, the joint density of x and y. Please, first of all, will make these functions into x and y. So how this will? So this equation 1 and 2, how they will look like. So I'll write down the equations here. W equal to x plus 2y, and there is another function z is equals to 2x plus y. Okay, 2x plus y, 2x plus y. So okay, what is x then in this case? I'll have to multiply with 2 here above, so this will become 4, uh, and if I subtract it, what I'll get? 2w minus z equal to, so this will get cancelled, and here it will be 3y. Basically I'll get y as uh, 1 by 3
2W minus Z by
2w minus z, right? Okay, similarly I'll write down this again, or I can plug in the value of y and I can get the equation of x, or I can do one thing as, let's say this was the original equation, right? W equal to x plus 2y, and z equal to 2x plus y. So what I can do is, I'll just multiply by 2 to the second equation. This will become 4x, this will become 2, and I'll subtract uh, this equation from here, right? So the reverse subtraction. Okay, I'll write down this here. Will be w, sorry, be w equal to x plus 2y, and if I subtract it here, what I'll get? I'll get 2z minus w equal to 3x, right? This will get cancelled, and from there I can get x equal to 1 by 3 2z minus w. Is that fine? Or w minus or minus w plus 2z, whatever. Because if you wanted to make these two equations as, so what is x here? X equal to 1 by 3 minus w 2z, and y is 1 by 3 2w minus z, right? Okay. Now what is a Jacobian? Jacobian, so this is actually a function of r of w and z,
W comma Z.
right? And this is y is uh, another function of w.
S W comma.
So the determinant of Jacobian, so I'll write this determinant as like this. This determinant of Jacobian will be what? It is del r del w del r by
Del R by del Z. Del
s by del w,
del W del S by del Z.
or in other words you can say del x by del w also, right?
Yes, sir.
Because r of wz is basically x only, so that also is fine. So can you tell me what is if I differentiate this function with respect to w, partially differentiate this function with w, what will be the answer? Minus 1, right?
Minus 1 by 3.
Minus, yeah, minus 1 by 3, and here if I differentiate with respect to z, it will be 2 by 3.
Yes, sir.
What about this del s by del w? It is 2 by
2 by 3 and minus 1 by
3. So what will be the determinant of this? It will be 1 by 9
3. 1 by 9 minus 4 by 9.
which is minus
So
1 by.
minus 1 by 3.
So this is the determinant of
Mod.
Jacobian, but we need to take the
Mod.
modulus of determinant of
1 by 3. 1 by 3.
mod of minus 1 by 3, which is equal to 1 by 3. Now what is the next step? I need to plug in these values into this function.
In the joint.
Yeah.
Whether.
So basically, then the joint density of
Sir,
W is Z.
small question, sir.
Yes, yes.
When we do this method, do they have to be independent?
What do you mean by independent?
Independent random variables,
Which ones?
x and y.
X and Y, not needed, right? Okay. If it is not needed, if the joint is, it's not needed that they should be independent. If they are independent, then it's okay. If they are not, it's not a problem.
Not a problem. Okay, sir. So one
They-
more small question.
Yeah.
Dou r by dou w.
Yes.
Here, there, here x is equal to some function.
Hmm.
What do you mean by dou r by dou w?
This is the function, right? R of w is this. So basically, I'm saying that dou r by dou w is basically dou x by dou w only, because x is r of w comma z, right?
Oh, okay, sir. Got it, sir.
Yeah. So either you can write dou x by dou w, but it is written separately so that you should get the distinction between x and y, which x I should use it, right?
Yes.
Yeah. That's all.
So here it's just dou x by w. Same.
Yeah. And
Got
s is y. Basically, you are just differentiating above y with respect to w and above z, because that's why I written it here that x is a function of some r function, right? Generally we write functions as f of something or g of something, right? But
Yes,
you
sir.
already are using f for joint density of x and y, and g for joint density between w and z. So again I cannot write that function, right? So basically x is a function of w and z, but what kind of function? Some r of wz, and y is a function of w and z. This function is defined by s here.
Sir,
Okay.
got it. Sir, here in this case, it's a special case where dou r by dou w is equal to a constant value. It might also,
Yeah.
there might be a variable, no, sir?
Correct.
Then what are we supposed to do?
That also is fine, no issues. In that case also we will get the answer. That also will, like, it will not stop, right? Because suppose it is x, it is suppose here it is x by 3, and here you will have y by 3. What will happen then? I'll just write down x by 3 and y by 3, and whatever comes out, right, I will take that in account. Why it will not affect, I'll tell you. Maybe just a minute. But that's not a problem. Okay, that will not also stop
Okay, sir.
from there.
Got it.
Fine. You can just so your determinant of Jacobian basically will be a function of x and y in that case, right?
Sir.
Okay, then g of w of z, or sorry, not function of x and y. It will be function of w and z. But basically, we are trying to find out the joint density of w and z, right? And the joint density of w and z will be a function of w and z anyway. So it will just multiply with that part. Fine. Okay. So basically, we will have to write this is the formula, right? F of x y, x comma y, right, into
The Jacobian.
yeah. Fine. This was a problem. And what was x? X was 1 by
1
3
by 3 into 2w minus z.
minus, yeah, or minus w plus 2z.
Minus z plus 2w.
Yeah. And
Minus
y,
w plus 2.
yeah. And y was 1 by 3 uh, 2w minus z, I guess.
2w minus z.
Yeah. Right. So now I'll plug in the value of x here and value of y here. So it will become joint density of 1 by 3 minus w plus 2z and 1 by 3 2w minus z.
2w minus z.
And what is the Jacobian? Determinant of Jacobian.
1 by 3.
So this is some x and this is some y, right? What is the value here? We'll get it 1 by 6, right? Because it was given to me that joint density between x and y is
1
1
by
by
6.
6. So any value I'll put it here instead of x and y. For every values of x and y, it will take or it will throw the constant joint density, right? Is it fine? This is the value of x I put here, the value of y, but it will be 1 by 3, 1 by 6, and into 1 by 3. So the joint density of w and z is 1 by 18. What is the meaning of this? It is uniform, right, over w and z. Basically, it is uniform over that support of x and y. Correct. Now you understood how to find out the joint density. Let us try to see the support. Right. What was the support of x and y? So if you look at the example again, what is support of x and y? So these were
X is
the
equal
range.
to 2.
So if I try to draw the support here, let's say it is x here and y here. X is between 0
0
to
and 2.
2 and y is between
0 and 3.
3, right? So the support was the area between this, right?
Area under the curve.
Yeah. So this is a support of x and y. But and what was the density of it? It was 1 by 6 over this area,
1
right?
by 6.
And that is actually going into the third direction, correct? And if you integrate over this, then you'll get the value as equal to. So if you integrate this density 1 by 6 over this box constraint, it will be equal to 1. But now we have found out the g of w and z, but what will be the support of it? We need to find it out again. So how to find out this support? So we have to find out the range of what? W and z, right?
W and z.
Okay. What is, again, I'll write down once more. What is x? 1 by
Minus w plus 2.
y is 1 by 3 into
2z minus w.
Okay. Okay. Now, if what are the values of x? X is actually taking between 0 and 2, and y is taking between
0 and 3.
So we'll see the extreme cases first. So what is at x equal to 0? What this function will look like? It will become 0 equal to
W equal to 2z. W equal to
2z, and that means uh, w equal to 2z.
2z.
Right. Okay. At x equal to 2, this function will be 2 equal to 1 by 3 minus w plus 2z. So that will give me what? This will become 6 equal to minus w plus 2z, or in other words, I can say that w equal to 2z minus 6, right? Is that fine? It's okay,
Yes.
right? You are not getting confused between 2 and Z, right? It looks like
Almost looks the same, but no.
fine, right? I think I'm just, that's why I'm speaking, but yeah, I'm not able to distinguish it. Okay. Okay. And what are the values of y? If y equal to 0, then this equation will become 0 equal to 1 by 3 2w minus z. That gives me w equal to,
1.
W
no, z by 2, right?
W equals Z by 2. Yes.
Or 1 by 2 z. Is that fine?
Yes, sir.
Yeah. And if you have y equal to, what should I take? Y equal to 3, right?
Y equal to 3.
Yeah. So this extreme case. So y equal to 3. For y equal to 3, it will become 3 equal to 1 by 3 2w minus z. So this will be 9 equal to 2w minus z. So then w will be equal to, okay, I will put the box here. W will be equal to 1 by 2 z plus 9, right? Z plus, yeah. Is that fine? Is that okay? So we have got this values for w and z now. Why I have done that, right? Again, because see, I wanted a support. So can you tell me the support here will be, so previously we have seen the support. It was between which random variables? X and y, right? So
Yes, sir.
on this horizontal axis I have written x, and on the vertical axis I have written y. Here in this case, what should I write down here?
So
So
we have
it,
to find the solution between these two.
not solution, we need to find it out. We have to draw this lines, equations actually. It's basically all of these are lines, right? With different slopes and different intercepts. Can you see that? So consider w as y and z as x. Then you can look at this equation as y equal to 2x. This is y equal to 2x minus 6. This is y equal to 1 by 2x, and y equal to 1 by 2 x plus 9. But now it's, they are not x and y's, they are w and z's,
W and
two
Z.
different random variables. So if I try to put them here to find out the support, what they will look like. So on this horizontal axis I should write z, and vertical axis I should write w. So the first equation, if I try to draw, it is w equal to 2z. What does that mean? The line, the intercept will be the origin, right? Okay, I'll
Yes.
do one thing.
Origin.
Yeah, sorry, I'll do one thing. I'll just write the short, the smaller figure possibly, so that, yeah, be w and this will be z. So okay, can I write down? This is fine, right? Or shall I write down all these equations here separately? That's okay, right? So for this,
Yes. Which one?
w equal to 2z is where?
Origin.
So this will be what? This line will be w equal to z, right? So w equal to z will be, so this line will have slope as equal to 1, right? Which is 45 degree. So if I have more slope, the line will be here or the line will be here. So this A or this B, where should it be?
B B.
B, right? So if the slope is higher, then it will try, it will be like closer to
Closer to Z axis.
z axis, right? Yeah. So this is my line of what, it is. Okay, I'll write in different color here. This is line of w equal to 2z, right? Okay, now I need to draw this one, w equal to 2z minus 6. So what is the intercept here? uh, what is the x intercept, or the, sorry, rather I should say w intercept is, when z equal to 0, that has to be equal to 6.
Minus 6. W will be minus 6.
Z equal to 0, w will be minus 6. So will that line be parallel to this? Now you just look at it. What is the slope? The slope of this line w equal to 2z and the slope of this line
Same, slope is same.
slope
2.
is same. The only thing is the intercept is
The intercept will be
yeah.
changed.
So that line will be parallel to this line, right?
Right, yes. Only it will cut at negative of this thing.
Not negative, positive.
Oh, positive, sorry. Yes.
Correct, right? Or so if it is this line, then this has to be like this, right? I hope this is fine. Yes, right.
Because at z equal to 3, w will be 0, right?
So okay, basically at this point, right, this intercept, the equation of line is 2 w to 2z minus 6, right? So this point w is equal to 0, right?
But sir, at z equal to 3, w will be equal to 0, right?
Z
So
equal,
it should be actually in this side, towards the left side of w equal to 2z, right?
no, at okay, let's say this point, right? This point,
Yeah.
what
Z
is
is 0.
z is 0. Okay, z is 0, and then what is w then? It's minus 6, huh?
W is minus 6. In this case, W is 6, right?
Sir, here if you take w as the x-axis, then the slope should be 1 by 2, no, sir? The
Ah,
form is y is equal to mx plus c.
Correct. He's correct, sir, actually.
what is it? Sorry, what is it?
So
Actually, W will have to take as
Ah,
y-axis in this
yeah,
case.
Sorry, I think I
He's
previously
correct,
told the
correct.
truth. Sorry, and that's why the confusion here. Yeah. Okay. It's W and this is Z.
Yes. Now it's correct.
That,
Yes. Now
yeah,
this
that's
line will
how
be correct. Yeah.
correct. Correct.
Correct.
I was also thinking that way, but I just wrote it wrongly. Yeah. Fine. Okay, right now that's fine. So this is what is then now W equal to 2Z minus 6. Right. Okay. Uh, yeah, fine. That I think that way is correct. Yeah, because then Z equal to 3. So I think this intercept will be 3. Fine. Okay. If I try to draw this one, W equal to half Z, where that line will be. So I think it will be like this. Correct. I'll say that it is W equal to 1 by 2 Z, right? Because if this was the slope, right, this was like towards the W, this has to be towards the Z line, right? Because it is half, and now it is half Z plus 9. Where it will be then? Will be cutting somewhere here, which is that line also will be parallel to this. The only thing is it will be like cutting like this, correct? And the equation of this line is W equal to half Z plus 9. Is it fine? Or you can actually look at this line as like this, as half Z plus 9 by 2. Is it fine? All these four lines are okay. W equal to 2Z, W equal to half Z, W equal to Z minus 6, and this was. So I have done that. Where will be the support then in this case? Which region will be a support?
Bounded area, basically.
Yeah, right. The bounded area will be support. And what will be the probability density over this support? One by 18, right? We already have
Okay.
calculated it. Basically, okay, I wrote it as G, right? G of I hope it is clear how to find out the support. So, how will you write down the final solution to this? The G of okay, sorry, G of WZ of Z equal to you can say it is 1 by 18 over when. Okay, you can write either all these equations or you can write it compactly also.
We can write the coordinates also, right?
You can
Something like
coordinates, I don't think it will work right in that way. We don't have exact coordinates,
correct, correct, correct,
right?
correct, correct. It won't
So
work.
either we'll have to write it in terms of w's or z's, but I'll just write for now. I'm writing it as let's say only
So if
uh,
we solve the equation,
support.
won't we get the coordinates?
No, you'll get the coordinates, but they are not exactly bounded by that, right? So here, like this is slope,
Yeah,
right?
it's a parallelogram. It's
Ah,
something,
yes,
yes.
got it.
If that will be the box constant, right? You can
Box
definitely write
constraint,
down. This
yes.
is not like that. And I think one of the lectures sir has written, right? I think when he was saying about the joint density between the transformed random variables, he showed like this, right?
Yes.
It is converted from this to this,
A parallelogram, something like that.
right? So the meaning of that is this. So whatever the constants are there, right? They're actually transforming
So
to.
basically, we can write the equations, right? Then
Yeah.
those
You can write
those.
the equations or you can write yeah, it's like basically you need to write the equations only, or you can somehow you can make it like between z is between this and this, or w is between this and this. That also you can do it. So you can basically find it out, but I will leave it that with you. I'm just writing it as support here, and 0 otherwise. This is going to be your final solution. Is that correct? I hope this is fine now. So we'll solve one more problem. Now I'm giving you a problem. You need to try it out. Fine. I'll just give you like maybe 5 minutes to solve it, and then I'll solve that. Is that okay? So suppose x is a random variable, which is exponential random variable with lambda equals to, let's say, 2, and y is a random variable with which is uniform, let's say. Is you just don't find out the support and all. You just find out the joint density for this. Uh, let's say it is uniform, or it is like continuously uniform, right, over the interval. Okay, I'll just write down the interval uniform between 0 and 2. X and y are independent random variables. Independent random variables. Okay. They are okay. And now I'm saying that y equal to w plus z, and and not y, sorry. Yeah, okay, y, and x is equals to w minus z. I can just reverse it out. Sorry. Fine, that also is fine, but okay, maybe I'll just writing out w equal to, let's say, x plus y, and z equal to x minus y. Fine, this is okay. Now I need to find out what is the joint density of w and z. Can you try it for 5 minutes, and then we can see the solution? Do you need the formula? I'll write down the formula also here. So that is of z equal to fxy of r of wz s of wz and mod of limit of Jacobian.
Sir, yeah, sir, I had one doubt. In one of the lectures,
Hmm.
so could you please write once prop f
Yeah.
of x is equal to x by 2 if x belongs to 0 to 2.
What is it?
The probability density function is x by 2 if x belongs to 0 to 2.
X by 2 when x is between 0 to 2. Okay.
0 otherwise.
Okay. That's okay, right?
Yes, sir. And he gave a condition a is a the condition a is x is greater strictly greater than 1.
1. Okay. What is the probability that x is greater than 1 now?
Sir, what is the write the probability density function of x given a? I did not understand the solution, sir, at all.
What is it? What is it? We need to find out
Probability
this or what?
probability density function of x given a.
Oh, conditional density it is asked.
Yes, yes.
Okay. Probability density of x given a, yeah?
Given a, and a is the condition a is equal to x greater than 1.
So basically you wanted to find out probability of x given x is greater than 1.
Yes, sir.
So this will be, let's say this is event A and this is event B. What is the conditional density here? It should be probability of A given B, right? Your probability of B, or not A intersection B, right? A intersection B. Okay. What is the probability of A intersection B? So X is basically like entire range, right? X is over 0 to 2, and
Yes,
B
sir.
is X is greater than 1. So what is the common here? So it is actually kind of finding probability that X is greater than 1, right?
Yes, sir.
And sorry, and what is this is it below? Okay, I don't know why it is not working. And I think divided by probability x is greater than 1, right? So it should be equal to 1.
No, sir, that's not the answer. Answer is 0 if x less than 1, 4x by 6 if x between 1 and 2, and 0 if x greater than 2.
Okay, so it is kind of like it is taken as a piecewise function, huh? So
Yes.
x can, okay, but it's fine, right? I think it's this is okay, right? Between less than x. So if okay,
No, sir, in the lecturer explained this, sir. It's
I don't know. Maybe it is kind of like that. It's kind of, let's say, when what is the conditional probability that x is less than 1, given probability that x is greater than 1. That has to be 0, right? Because there is no intersection between them. When what is the probability that x is what is it? Next one is what?
between 1 and 2.
Between 1 and 2. Okay. So when but between 1 and 2 should be 1, right?
Yeah, it will be x greater than 1 by x greater than 1, right? It
Hmm.
should be 1 actually.
Hmm.
Common intersection area will be x greater than 1, right?
Yeah, that's what. What is the answer given there? Where it is
Sir, could you
given?
once go to the this thing slides if possible? The no, the lecture slides.
Okay.
Sir, can you just
It's there clearly in that, sir.
Okay. Fine. Okay. So I'll remove this.
I said
Yeah, yeah, just a minute. After that, I'll try. I'll solve this problem and then we'll start this.
so can we do this one first and then move to that?
so this,
Okay.
this we
That's
can
fine.
do at the end as well. I
Yeah.
thought we had some extra time in the
Yeah.
middle.
Sure. No, no. My if I understand it properly, it should be like this. But we'll see. What is the? Okay. Have you guys tried it out? uh, I hope you have tried it out. Let me solve it, right. So here it is given as x is given as this, but I don't have given the joint density explicitly. But if they are independent, what do you mean by that?
Product multiply
Yeah, the joint density of x and y, if the x and y are independent, is basically
fx and y.
uh, yeah. So it is a multiplication of their PDFs, right? And what is the f of x here? If
2e
x,
power minus 2x.
yeah. So x is exponentially distributed, so it is lambda e to the power minus lambda x. So lambda is 2 given to me, 2 to the power minus 2 x, right?
X.
And
Okay.
what is y? Y is uniform between 0 to 2. So the joint density, sorry, density, its density is 1 by 2, right? 1 upon b minus a. So b is 2, 2 minus 0 is 2. So basically you will get e to the power minus 2x as the joint density of x and y. Fine. Now what else I need? I have given these two equations, w and z. They are already in terms of x and y. I need to convert them into x plus y, and z is x minus y. So if I add these two, what I'll get? 2x equal to w plus z. That gives me x as w plus z by 2. And if I subtract the second equation, oh sorry, x y, right? Sorry. I think it was corrected. Something, okay. Let's do it properly. Okay. It has to be okay. So if I add this to equation, I'll get w plus z equal to 2x, right? And that gives me x as w plus z by 2. And if I subtract equation, let's say this is equation 1 and this is equation 2. If I subtract equation 2 from 1, what I'll get? So basically I'll have to do this calculations, w equal to x plus y and z equal to x minus y. If I subtract it, I'll get w minus z equal to 2y, right? That gives me y equal to w minus z by 2. So now I'll plug in all the values into this formula. This is what formula given to me. And before that, I need to find out this Jacobian, right? So this Jacobian is what? So this Jacobian is, or rather determinant of Jacobian. Determinant of Jacobian is this one, right? Del x by del w. So it will be half del x by del z is half, del y by del z is half, and del y by del w is half, and del y by del z is minus half. So from there, what I'll get is minus 1 by 4 minus 1 by 4, that is equal to minus 1 by 2. But we can uh, find out its, like, we'll have to take its mod, and that mod will be plus half, right? So if I now plug in all the values, I'll get g of wz as what? Fxy of x comma y. What is x here? X is w plus z by 2. Y is w minus z by 2. W minus z by 2. And its Jacobian is, or determinant of mod of determinant of Jacobian is half. What is fxy of y? Xy?
E power minus
E
2x.
to e power minus 2x. So it is basically, and what is x here? This value is basically
W
x,
plus z by 2.
x, and this is y. So my joint density is a function of x, right? It is free from y. So basically it is e to the power minus 2x. X, instead of x, I'll write w plus z by 2 into half. So I can actually write it as like half. Either you can write it's like uh, minus, or basic minus of w plus z, or further you can write e to the power minus w into e to the power minus z. So that is my g of uz of u comma z. Fine.
Sir,
Yeah.
yeah, in that formula which you just substituted,
Hmm.
uh, Could you just show me the original formula, sir?
Yes.
Okay, so I didn't understand this part. Could you
Which
explain
part
it
you
once?
don't understand?
I mean, the substitution. I didn't understand how you substituted that.
Okay, what is known to me? I know this f of x comma y, right? So joint
Um,
density of x y I know, right?
joint density of xy. How do I know that?
Here x is this, y
Yeah.
is this, right? X and y are independent.
Yes.
If they are independent, what is the joint density between x y? It is basically fx of x, right, into f of y, fy of y. If you remember it from stats,
Okay.
it's a multiplication of two uh, densities, right? Or densities or probability density functions of x and y individually. What is f of x here? What is the PDF of x?
Mm,
So it's exponential distribution, right? With lambda
yeah.
equal to 2.
Yeah.
What is a PDF of exponential? We have seen that it is lambda e to the power minus lambda x, right?
Right.
So lambda is equal to 2 means it is 2 into e to the power minus 2x.
Yeah.
Okay. Y is uniform distribution. What is the PDF of y? 1 upon
2/2. Yeah.
say, so it is 1 upon 2, right?
Yeah.
So if how to find out its joint density here, this into
One by
this.
two. Yeah.
So it is 2 into e to the power minus 2x into 1 by
One by
2.
two.
So 2 to get cancelled, I'll remain with e to the power minus 2x. So this is the joint density which is known to me, right?
Right. Yeah.
Okay.
Got it.
So I have then found out x and y in terms of y and z, right? So this is x,
Yes.
this is
Yes.
y, right? So my joint density was what? It is known in x and y, right? So what is the value of x here? Basically, x value as w plus z by 2, and y takes value as w minus z by 2, right?
Correct. Yeah.
So here, when I say that it is x and y, right? So wherever x is there, I'll put w plus z by 2, and wherever y is there, I'll put w minus z by 2. Fine.
But the formula is different, right? I mean,
Formula is
that
what?
what was that formula? Maybe that is where I didn't get it at all.
This is
Yeah.
right. R
Yeah.
of w z. R means what? Actually, it's a function of w and z, and s is a function. Sorry, it is a function of w and z. But basically, if I write joint density of how do I write joint density generally? Like this, right? Two values
Correct.
of x and y. So it is like this first value is corresponds to the value of x, right? And the second value actually correspond to the value of y, right? That's okay, right?
Correct. Yeah.
When I write in these terms, this becomes what? This part becomes x, right? And this
Hmm.
becomes y, right? Because before comma I should have x, and before and that it should be y, right? But I'm saying that this x is some function of w and z, fine, and y is
Okay.
also some other function of w and z. And what is that function? This x
Got
actually we have found it out as w plus z by 2, and y is we have found out by this.
got
So this x I can write it as r of w comma z, and this as s of w comma.
it. Yeah. Okay. Got
And
it, sir. Yeah,
I'm just
thank you.
yeah, I'm just plugging in here. So wherever x is there, I'll plug w plus z by 2, and wherever y is there, so, and then in that case, it was e to the power minus. I think it was 2x, right? So 2 and x is w plus z by 2. This 2 to get cancelled. I hope now it is clear.
Yes, sir. Yes. Thank you.
So is it clear to everybody? Okay, fine. Yeah. Okay. Now, what was the question? Okay, I think you have asked me to say show this, right? Which one? Which PDF?
Sir, week 11, lecture 2.
Conditioning.
Could you go a little
Yeah.
more down? Sir?
Okay.
It's not in here, sir. In the dashboard, it was lecture 2.
Okay. Is it uh, okay, maybe. This one conditional case.
Yes, yes. Uh, Somewhere 3/4, 75%, I guess. Little bit more front. Yeah, yes, yes, little bit back,
Right, back.
the back, sir, yes. Little bit more back, sir. Little, just little. Yes, sir. This one.
I don't think it is a conditional density, right? It's something else. Uh,
Sir, it's conditional density only, sir.
yeah. So exactly, see, sir has actually found out if you, this between this and this, right? If you hear it properly, are you guys able to? When I was running that, were you guys able to
No, sir. No, sir.
sound
We
it?
can't hear.
Okay, so at when you hear it again, right? He's saying that probability has to be equal to one. When x is greater than 1, the probability has to be equal to 1. But how it is changing? So what he has done is, given that x is greater than 1, right? How that x is changing, that is given to me actually. So that is what he has shown right here. It's not like it is not taken between 0 to 2. He has taken piecewise things, I guess. And okay, okay. Uh, 2. Hmm. Hmm. So see, he has written it correctly, right? The only thing what he has done here is he has not taken the entire interval. So when it is the this is actually he is finding out the probability that x, let's say x, given that x is greater than 1, right? So the event A. So we are actually finding out the probability that x is between 1 to, let's say, 1 plus x. Fine. And what is the density function? X by 2 dx. Uh, or okay, just maybe I'll just write it down. So it's like probability. So x and intersection of x greater than 1 divided by probability of x is greater than 1. That is what we actually finding out. Yeah. So what is upper side? It should be
1 to 2, sir.
not 1 to 2. If I take 1 to 2, right, then it will become 1. That is anyway 1. But let's say it's for smaller interval, over the small interval, let's say x plus dx interval. That will be what? Say it is x plus dx. Then that will be the probability of x plus dx only, right? And divided by probability that x is greater than 1. And you will have to find out this probability by saying that it is 1 to x by 2 dx divided by what is probability that x is greater than 1? Is 1 to, I think, 2, right? That has to be actually
Right.
by 2 dx. Now this the above one will become what? X square by 4, right? Square by 4
2 by 4 minus 1 by 4.
by x and divided by x square by 4. Okay, what? So this will be x square by 4
Minus
minus
1.
1 by 4, and here it is
3 by 4.
4 by 4, 1 1 minus
3 by 4.
just 3 by 4. So then I think, to think about it, it's x square minus 1 by 3, right?
3. Yes.
Something like that it will come out. Or I think he has written in some other way, but this has to be like this. So, so it is like how it is changing over that interval, right? If you change it, change the interval. So 3 by 4, see it is already there, 3 by 4 here. Okay. And so then I think he has written between 0 to 1. Okay. This is the function. It actually comes out. Yeah. But that 4x by 6 is coming from where? Okay, probably. See, I understood it on the like broader level, but if you can, if you don't understand it, right, like let me go through it again, and maybe I will make this
So
match.
no problem, sir. I think I got it.
Yeah.
So what I understood is it is as you just said, conditional.
Yeah.
So if we use it in density,
How
I remember in
exactly?
stats 2 as well,
Yeah.
fx given ax is equal to fx, so the joint probability divided by p of a.
Correct. Correct.
So if we do that, we were getting it, sir. It's
Yeah. So the thing is, it's like you will have to see that how, what is the variation of conditional density over that period.
right, sir.
That is what it is shown there. If you find out exactly for what are the, for x is greater than 1, right?
Yes, sir.
Between x and 1 and 2, that interval, then it is going to be obviously 1. And sir has also have mentioned that there. If you just look at the first part, right, you'll just listen it carefully. Sir has said that uh, given that x is greater than 1, what is the probability? It will always be equal to 1. But what he has shown is what is the variation of probabilities, right? The conditional or conditional densities across that, or between 1 and 2. Before 1, definitely it is 0, given that x is greater than 1, right?
Got it, sir.
And greater than 2 also it is 0. So in between, what is the variation? That variation is captured by that term 4x by 6.
Got it, sir.
Okay. Yeah. Okay. So we'll stop it here today. I think Saturday when we'll meet, we'll talk about the transformation of whatever we have learned it today, right? Transformation of two random variables. We'll take it to the multivariate random variables, and basically we'll be talking about the standard normal variate and in like maybe two-dimensional case, and or that is called bivariate and multivariate case. Fine. Okay. 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 Good night, all. Bye bye. Thank you for joining.
Thank you, sir.
Thank you, sir. Yeah.
Thank you.